sketch the following signal. So here a continuous signal is given and you have to sketch accordingly. U of t minus 2 plus u of t minus 4. They have asked you to sketch. So u of t, you know, it is nothing but unit step function for which you have to draw the signal u of t. So according to the formula, from 0 and after 0, that is when n or t is greater than 0, your amplitude will be 1. So this is how a u of n represents. Next we have to draw for u of t is asked. So for u of t, it's said it is shifted twice to its right, that is a delayed shift takes place. To draw this, please draw t is equal to 0, t is equal to 1, t is equal to 2 and so on. Here you have to deal with t is equal to minus 2. So t is equal to 2, t minus 2. So that gives you t is equal to 2. So here t is equal to 2, t is equal to 3, t is equal to 4 and it will go on. It starts from t is equal to 2. So I've started from t is equal to 2, it will move on, okay, and the amplitude will be 1. Similarly, for t is equal to minus 4, again t is equal to 0, t is equal to 1, t is equal to 2, it goes on. Okay, now here you have to say, you have to find out for t is equal to 4. That is t is equal to minus 4. So add those, plus 4. So add those plus 4 to everything. T is equal to 4, 5, 6, 7, 8, 9, it goes on. So we'll start from t is equal to 4. Okay, so in both cases, a delayed shift takes place. Here, delayed shift by 2, here delayed shift by 4. So your t, which was supposed to start at 0, will start at 4 and it will go on. The amplitude will not change, it will be 1. So we have found u of t, it's found. So the first thing is u of t minus 2. This is found. Second is u of t minus 4. That is also found. Now it is time for us to find the signal that has been obtained by adding the two. So now let's add the two signal u of t minus 2, u of t minus 4 to get the signal that has been asked. For that, draw, as I said, while adding the two, take the larger number of instances. So here the 6 is the largest. Okay, and the amplitude, and this goes on. Now we are drawing for u of t minus 2 plus u of t minus 4. So this is a signal for u of t minus 2 plus u of t minus 4. Now at 0, what is the amplitude? 0. Here 0. So it will be 0. At 1, no amplitude. But at 2, you have 1 here and there is 0. So 1 plus 0 is 1. Then at 3, again 1 and 0. So 1 plus 0, again you have 1. At 4, at t is equal to 4, see the amplitude is 1 here, whereas the amplitude is again 1. So 1 plus 1 will fetch you 2. Then comes 5. Again 1 plus 1, 2. 2, 2. It will go on. Okay. So now the new signal. This is the new signal. Okay, it has been drawn by adding u of t minus 2 and u of t minus 4. Next, we are going to see 3 problems at a stretch. So all the 3 say sketch the following signals. You have 3 different types of signal. First is r of minus t plus 3. That is your ramp signal. Okay. Second is u of n plus 2, u of minus n plus 3. Third is 2 del n plus 2 plus del of n minus 2 del of n minus 1 plus 3 del of n minus 3. N minus 3, yeah. So all the three has different signals. First is the ramp signal, then comes unit step signal, and the third is the delta signal. First we'll go with the ramp signal. So this is your ramp signal, R of t. Okay. Here two things are given. When you say R of minus t plus 3, this represents advance shift, and minus t represents time reversal. So here shifting and reversing has been asked to do. So this is R of t that has been done. So when we'll do shifting and then we'll go for reversing. When we say shifting, it is move to left side by 3. So now it starts from 0. Step 2, you're going to shift towards left by 3. 1, 2, 3. So from here, the ramp goes on. This is R of t plus 3. Okay. This is R of t plus 3 here, and an advanced shift has been taken place. Next is time reversal. So from the signal from here, it will go to the other direction. So from minus 3, it will move on to plus 3. 1, 2, 3. So now this is your signal. From minus 3 to this direction, it will completely reverse itself. So now the new signal is R of minus t plus 3. This is the new output signal that has been obtained. So we have done the first one. Let's do the second problem. The second problem, u of n plus 2 into u of minus n plus 3. Here two signals are taken. Two signals are considered, S1, S2. When you multiply, you will get the full signal u of n plus 2 into u of minus n plus 3. So when I say u of n, you know u of t is the unit step function. You draw it like this. We just now solved a problem. Next is u of n. So the same thing in discrete time domain. Same thing in discrete time. This is u of n. Okay. So you know what is u of n now, right? I'll redraw it. U of n is nothing but when n is equal to 0 or greater, you have amplitude 1, and this goes on. Okay, so you just considered 4 instances. Now let's take u of n plus 2. So this is your signal 1. Okay, so this is signal 1. So when we say n plus 2, there is a shift, there is an advanced shift, okay, by 2. So for this, the new signal will be, instead of 0, it will start from minus 2. As I said, we are only considering 4 instances, okay. So that's enough. This is u of n plus 2. Okay, so we finished with the first signal. Now let's consider the second signal. U of n plus 3. Leave this minus. First we'll do the shifting and then we'll do the time reversal. Okay, now u of n plus 3. So that means it has been advanced shift by 3. Okay. So here we'll start with minus 3. Second instance, third instance and fourth instance. Okay. So this is u of n plus 3. See, it has been shifted by 2. It has been shifted to left by 3. So advanced shifting and advanced shifting. Okay. Then they have asked you to do u of minus n by 2. We'll do it here. When you say minus n, from minus 3 it will go to plus 3. This is nothing but your time reversal. Okay, this is nothing but time reversal. N is equal, this is n. Okay, so you have reversed the two signal. So what will be in your x-axis? It will be u of minus n plus 3. Okay, now you have been asked to add n into u into n plus 2. That is the signal and u into minus n plus 3, this signal. You have been asked to multiply these two signals. Okay, so let's draw the last signal. For this, take the maximum number, minus 4, minus 3, minus 2, minus 1, 1, 2, 3, 4. And this is n. Now, multiply the 2. So, at minus 2, what will get? Here it is 1. And here it goes on. So, here again it is 1. So, this will be 1. At minus 1, the amplitude is 1 here. Here this goes on. So, here also the amplitude is 1. So, 1 into 1, 1 again. At 0, small mistake, this is 0 and this is 1. Okay. So, at 0, 1 into 1, 1. At 1, 1 into 1. At 2, again. At 3, again. Okay, do not draw beyond this because we have only considered 4 instances from the starting, right? So 4 instances, this is 4, again 4. So adding these two, you will get the final. Now this is nothing but u of n plus 2 into u of minus n plus 3. So this is the new signal that has been obtained by multiplying two signals. The third problem, 2 del n plus 2 plus del of n minus 2 del n minus 1 plus 3 del n minus 3. So you're asked to sketch the following signal. Before we move on solving the problem, I'll just tell you what exactly is asked here. Okay, now when we say 2 del into n plus 2, here they have asked amplitude scaling. They have asked you to do amplitude scaling by 2. Here n plus 2, that is advanced shifting. Shifting at its left. This is a normal signal, so no worries. Minus 2. Amplitude scaling again. Amplitude scaling but in opposite direction. Okay? Since minus 2 is given. Now again minus 1. Minus 1 refers delayed shift. Delayed shift. Then again 3 is your amplitude scaling. And finally minus 3 is the delayed shift. So here amplitude scaling and delayed shift alone has been asked. There is no time reversal and there is no time scaling also. Fine. So here the signals are added at the end. So what you have to find each signal separately and finally add 4 signals, 1, 2, 3 and 4 to get the final signal. Let's start solving. First we'll see what is del of n. So del of n is the delta signal, a discrete time signal. It's given by the formula only when n is equal to 0 you have an amplitude 1. So this is del of n. Rest everywhere it will be 0. So you have studied in the standard signal or basic signal, only when n is equal to 0 the amplitude will be 1. Okay, when n is greater than or lesser than 0 it will be 0. Okay, so this is what you have studied. Fine. So this is the diagram for del of n. So we have found del of n. Now let us draw it separately here. Okay, this is del of n. For you, no need to draw it separately. Draw one below the other. Okay. Next, so this is found. Next, 2 del n plus 2. Let's solve for 2 del n plus 2. For that, first do the advanced shifting by 2. Okay, so when you do advanced shifting, you have to move to left. So minus 1, minus 2. 2 shifts. Minus 1, minus 2. Okay. So this is del n plus 2. Then what have they asked you to? They have asked you to do amplitude scaling. So the amplitude has to be multiplied by 2. So your 2 del n plus 2 is given as, this is your amplitude 2. Minus 2, minus 1, 0. So you have found 2 del n plus 2. Now let's write this separately. 2 del n plus 2. Okay, so the amplitude is 1 here. Here it is 2 at minus 2. So we have found the first signal. We have found the second signal. Let's move on with the third signal, minus 2 del of n minus 1. I'll write it here. It's minus 2 del of n minus 1. Okay, so again moving from the last, here they have asked you to do delay shift by 1. Instead of starting from 0, you're going to start from 1. But the amplitude is going to be 1. This is del of n minus 1. Okay. Next is amplitude scaling is done. But in the reverse direction because minus 2 is there. Okay. So amplitude scaling in the reverse direction. Minus 2. So the new signal is minus 2 del of n minus 1. In the signal, okay, you have to do the amplitude scaling. 1. Okay. So now you have got minus 2 del of n minus 1. Let's draw it separately. It comes down 2. Here, minus 2. Here 1. This is minus 2 del of n minus 1. Now consider the last one. 3 del of n minus 3. So this is your initial n minus 3. So instead of starting from 0, you have to start from minus 1, 2, and 3. You are shifting it 3 times to the right side. Okay, so the amplitude is 1. So this is your del of n minus 3. Instead of 0, you are starting it from plus 3. Okay, next amplitude scaling by 3. So this is very simple. Scale it by 3. So this is 3 into del of n minus 3. 0, 1, 2, 3. Okay, so 3 del of n. Let's draw it here. 3 into del n minus 3. 0, 1, 2, 3. It goes up till 3. Okay, so you have got all 4 signals. Now let's take all the 4 signals. So we have got for all 4 signals. Let's take all 4 and add them. Okay, no need to subtract because we have also already considered minus 2 within the signal. So don't go on subtracting, just add the 4 signal. Okay, add these 4 signals. Okay, the first signal at 0 it is 1. So this is your first signal. Second signal, minus 2 of amplitude 2. So this is your first signal, that is del of n. Second signal, 2 del into n minus 2, n plus 2, sorry, 2 signal. The third at 1, now this is minus 2 del of n minus 1. And then the fourth signal at 3, you have amplitude 3. And this is 3 del of n minus 3. Okay, so this is the final signal that has been sketched by using 4 delta signal. So first write down the delta signal and then do one after the other. Take them separately and finally add them. You will get the last signal. So this is how you have to do for sketching the following signal.